Okay, let's take a look at Netstat and Tracert, two of the many exciting utilities in the TCP/IP suite of protocols. All right. There we go. So what do? Right? There are a whole bunch of utilities. Here is an example of two of them, Netstat, Tracert, and you can see a screen capture here of each. Okay. Netstat, in my personal humble opinion, is the more fun one. Tracert, however, is the more useful one, though it depends on what your issue is. So let's take a look at a little bit of each. Okay, Netstat displays TCP/IP statistics. Right, what does that mean? Well, let me grab a sample of one so we can look at it. So here we are with a a Netstat result. So I'll show you the original command here. Well, we'll explain, or at least give you a chance to examine what all those different switches are. But here's a Netstat result. And if you remember from the previous video, I said there's a couple different states it can be in, established, and I said active. Active's not actually it. It's listening or active. And I said active wasn't it, it's established. You'll also see time wait or close wait. If the remote destination has finished the communication, it'll be a closed wait. If you have, or your local machine has finished the communication, it's a time wait. So now notice these are all loopback addresses, right? 127, no place like home. But you can see the colon next to them. Those are the port addresses, right? So for some reason, well, it could very well be I had VM running too. That could be some of those. So not much we can glean off of that other than the ports that were being used. When we go down to the established connections here, we start to get a little more interesting. So you notice Chrome, there's 1, 2, 3, 4, 5, 6, so got half a dozen or more of those. I do not have 6 tabs open or a dozen tabs open. However, the tabs I do have open have multiple things going on. Ads from different websites, whatever it might be. So hence there's a whole bunch of connections. Now notice, 3884 local connections there, right? Let me see if I can find one. Here we go. Here's one that's my local IP address, 1.38, and a remote address. Core Sync is the application that's using that one. Down further, a couple more Chromes. Here we get a little interesting. 192.168 to a 172. Now I should be able to track that IP address and find out where that is, specifically what tab is hosting that. Notice the 443. Hopefully you recognize that. HTTPS, right? So it's a secure, right, socket. Here I have a local port, so the remote port versus the local port. There's a couple more down here. Oh, I think I passed it. I gotta find it now. No, I don't see it in here. Chrome. Oh, darn. I ran it. It was interesting when I was working on the PowerPoint presentation. PowerPoint came up because the application was there. Notice it's not there now because I'm actually running the PowerPoint. All right. So just an example of what Netstat looks like. Kind of useful information, right? It'll also display how many errors have occurred depending on what switches you're using. So let's look a little bit at those switches. Oops, sorry, gotta do this. There we go. So here are the switches. I'll let you review these. They're on the PDF. Go out and look at them. You can fool around with these as much as you like, and I encourage you to. Try Netstat a couple different times with a couple different one of these. I will warn you, however, that right, some of these switches, and I'm not sure which ones. Some of these switches require admin level access, right? Which means you have to run command prompt as an administrator. Command prompt doesn't always launch as an administrator, even if you're logged in as one. So before you use Netstat, probably a good idea to to launch command prompt as an administrator. It saves you from running it and not being able to run the switches you want. Not all Netstat commands or switches or options require admin level access, but many do. Yeah, nice important little tip. Don't forget the /?. I don't remember all the switches in Netstat, neither do you. So use Netstat /? to generate that list. Okay, these are some interesting combinations, especially this guy. we talk about the process ID and associated application. Sometimes it's not helpful to find just the IP address. What application is causing that IP? So if I'm suspecting communication going on in the background, what app is? PID, we can find that in, Task Manager, right? We can sort through the services or the Task Manager and look at the PID, trace it back to a service, trace the service to an application, etc. Right? So the PID is a good way to diagnose something that's running in the background causing network traffic or slowdown on a person's browser. Trace route, this is the Windows equivalent. The Linux actually spells out route. How sweet. Okay? It's odd that Linux takes more characters than Windows does. All right. Trace route in Windows uses ICMP echo requests, right? So you're basically using kind of ping, right? It's a tricky little deal, right? So it identifies all the intermediate hops by varying the hop count, okay? The Linux trace route uses UDP messages. Now, oddly enough, recently, I didn't know the really big difference. I said, well, what's the big deal? So let me bring this over here, and let me show you a trace route to google.com. Right now, hopefully it'll come up quick. There we go, and it should say Google, and I'm done, right? There is no way I am one hop away from Google, right? Verizon blocks the ICMP packets that traceroute needs to complete. I happen to be a Verizon customer. So it's showing me 2 hops from me to Google. I wish, right? So Microsoft using ICMP is being blocked. Well, not blocked, but Verizon treats those packets differently. If I open a Linux VM and do a traceroute command to Google, I'll see a number of different hops. I hadn't realized Verizon did that until I tried to prep for this video. Right, so tricky little traceroute. What I mean by that, by setting the time to live to the previous value +1, it gets routers to sort of forced response saying, hey, time to live is expired. Traceroute receives that response, adds 1 to the hop count, sends it down the first spot that already responded, passes it to the second one. The second one says, oh, hey, your traceroute time to live is expired, and lets you know. So it forces them to send a packet back. It's really kind of ingenious the way it does that, unless, of course, you're on a Verizon network and then it fails miserably. But it's kind of cool that it forces the nodes to respond by varying the hop count each time it sends out a request. Kind of cool. Right. Traceroute options. Again, they're on the Google slides, they're on the PDF version. Take a look at it. You can see it out there. But again, /?, do that. Let's play with traceroute a little. See if you can get it to vary. A couple different examples there. Again, I'll let you look over those at your convenience. Right? A trace might stop before reaching destination for one of 3 reasons. Device trace attempting a reach is down. That's how you know, right? I can't get past that point. Good. That's good information. It's too busy to process lower priority messages such as UDP or ICMP, right? And it does not accept UDP or ICMP transmissions being sent because a firewall blocks those. So a number of different reasons why traceroute would stop before reaching, right? If you run a traceroute from the same device at different times, it can produce various results. Why? Because routes change, right? If one router is too busy, it passes it over to another. When we look at routing in particular, we'll look at routing protocols and see how they handle overflow traffic, right? Your packets come to your machine from various destinations and various paths. That's why each TCP header has to have in it a sequence number. Which order do I arrange those packets in? Right? And that's the basic gist to traceroute and Netstat. Play with them. They're kind of cool. Get used to interpreting them. It's hard to use them in a vacuum when there's no issue that you know of, but it is interesting to learn how to read them. So take some time with it, read it, And if you have any questions, you know where I am.